Good. All right. So last part of Unit 4 here, new stuff. We are going to chat direct variation. And so as we look at this, I forgot to date things on Friday. That wasn't a good plan. So as we look at direct variation, every single one of those equations that we're going to deal with today have one point that every single one of them has. 0, 0. 0, 0 is a wonderful thing on many fronts, but the main front is going to be when you plug it in, it makes a lot of things disappear and makes a lot less steps for us to have to do work. So that's going to be nice. So for example number 1, suppose y varies directly as x. I'll explain what that means a little more here in a sec. And y equals 30 when x equals 5. Write a direct variation equation that relates x and y. You're like, okay, what does all that mean? Here's what we're going to do. One of your 2 points is still always going to be 0, 0. We just got done saying that. The other point that you're being given actually is being told right here. X is going to be 5. Y is going to be 30. And so you look, and this should look familiar because now we've got the ability, we've got the information. We're on page 4 of the notes for some of you still working around a little here. In getting into this part. So we can do the slope. So let's do this. y2 minus y1. And on the bottom, we got x2 minus x1. And the lovely thing again about 0 is 30 minus 0 is just 30. I didn't have to really do much. 5 minus 0 is 5. What's 30 divided by 5? 6. So I got my slope. But here's where the news gets even better. We're going to substitute m, x1, and y1 in, just like we do every time for point slope. I'll even put point slope over here again. Oh, I'm getting all... Let me just put these in quick so we can see where everything goes. So watch this. So y minus y1 is 0 equals m x minus x1, which is also 0. Here's why I'm so excited about this. I'm like, well, wait a minute. Y minus 0 would just be y. That's cool. And when I go to distribute here, 6 times x is 6x. 6 times 0 is 0. But if you're subtracting 0 from something, you're really not taking anything at all. So here's what's so good about direct variation, and it's so simple. Once you figure out the slope, you really have the equation already. You're just going to take that slope number, plug it in there for your m, and you're done. And that's going to be true every single time. And we're going to see that here as we work along. So, find y when x equals 2. Okay. So here's my equation. So find y when x equals 2, because they told me, hey, plug 2 in right there. I can get y. So you may not have noticed yet, but this is going to let me, this would let me graph a line. This would let me plug numbers in like we're doing here. There's lots of applications to this, but I have to be careful. Find x, when y equals 18. be careful where you're substituting based on what value they give you. It's not going to be x every time. Sometimes we may have to do a little bit of work to get to the place that we want to go. So as far as regular equations go, that's all we're going to be doing. And again, it seems a little more detailed because we wrote some extra things in, but that's just so when we get to the quiz, we got a little bit more info to help us on why did I plug that number in there? What was I doing here? And kind of see that. So of course, we haven't done this in a while, but hey, it's got to come around. We're going to have an application that we're going to do with this too, but it's going to go fairly quick. So our last thing to add to our notes, we move this down a little, is the direct variation word problem. So I look here, and they start talking about the distance formula, which is one application of many of direct variation. The distance formula, distance equals rate times time, is a direct variation equation. The distance varies directly as time, and the rate is the constant of variation. Now, don't worry about all the fancy language there. Here's what we're going to concentrate on. A family drove their car 225 miles, that would be distance, right? How far did we go? In 5 hours, that would be the time. So it says, write a direct variation equation to find the distance traveled for any number of hours. Okay. We know that the first point is 0, 0, because it is every single time on these. But then the question becomes, okay, so which one of these goes where? Does it matter? And it does. And here's what I always tell people to do when they're trying to figure this out. If I think about my regular, I'll even put the plus b here on the end. If I think of my regular slope-intercept equation, y is in the same place as d would be, and r is in the same place as m would be. So you're like, okay, so, oh shoot, I meant to do t. T's in the same place x would be. Dang it. So in other words, we'll just write it out. D is y, t is x. I could have just done it that way anyway, instead of trying to cute and draw pictures. So having that down should help me when I go to make my point, because now I go, oh, so t is x, and d is y. Once I get that one detail situated, I can go ahead and do my slope. Again, we're going to subtract our y's on top. We're going to subtract our x's on the bottom. Let's see here. It is, I believe it is. So there's my slope. And again, when I go to do my equation, we're going to substitute m, x1, and y1 in. I won't write the whole point slope form down again, because we had that in the last one. But if I plug in my m, and then x1 and y1 are always 0, that's always nice. what happens? Well, y minus 0, that just goes away and gives me y equals. Over here, 45 times x is 45x. 45 times 0 is 0. I don't even need it. So there's my distance formula version of direct variation. Okay? Or I could write it as, since y is d, I could write it as d equals 45t. You're like, well, why would I do that? Like, why would that be helpful? Why wouldn't I just leave it like this? And I'll take either. Here's why I think it would be helpful to have this as an option. Estimate how many hours it would take for the family to drive 360 miles. Right. That's just my y in here. So when I go to make my equation, whether I have it as d or y, it's going to be 360 equals 45x or t, because I'm plugging those two numbers in. So whichever one of those makes more sense to you, would get me where I'm trying to go. So that's why we like to make the notes flexible, because some of you may like y and x, some of you may like d and t, because that's what it's written in. And it just depends. But the nice thing is going to be, we're going to look at a couple more in the practice, so you can start to get a little more of a feel for it and see how this is going to work. So, I'm going to keep that handy. Let me put this over here. We are going to be playing with direct variation here. So, again, when you're looking and trying to find direct variation, you're like, okay, now how am I going to do that on a graph? We didn't do that on here. So what you're looking for when you're doing this is that x and y have some sort of a connection. So, for instance, when I'm trying to figure out, let me give you a hint. What was the one point we said every direct variation graph would go through? Okay, so every one goes through 0, 0 if it's direct variation. If you ever have multiple graphs, that should be the first thing you look for. You look at 0, 0 on each of the graphs. Do they both go through 0, 0? No, this one doesn't. So that's the one I want because it goes through 0, 0, as simply as that. Telling you this is going to be a straightforward lesson thing here. So then you're like, okay, well, what about graph each line and then determine if it has direct variation? Okay. So these are in y equals mx plus b. You're like, wait a minute though. Artie, there's no b. If there's no b, what is your b? 0. And then I would go, normally, down 2, and right 3. That's a little tricky because of the way this is. Close. Okay. Or I can change both of these. So instead of going down 2, I could go up 2. And instead of going right 3, I can go left 3. But you know what we're looking for. Does it have direct variation? Does it go through 0, 0? Yup. You're like, seriously? That's all I'm concerned with? Is it going through 0, 0? Yes. graph the line. Does it go through 0, 0? If it does, thumbs up, we're good. If it doesn't, thumbs down, not so good. You're like, okay, maybe. Maybe. I want to find another one here. There's one I want to do. Let's do 6. Oh, there's a method to Hardy's madness here. Okay, 2 points. We always know the first one. That will never, 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 ever change. And then you're going to get the other point from the values they give you. Be careful of the order. X always goes first. Y always goes second. And I do my slope. Again, subtracting the y's on top. Subtracting the x's on the bottom. You may even be finding a pattern with this. Nine divided by -3 is -3. And we're also going to use 0, 0 to plug in, because that makes life simple. Y minus y1 equals m x minus x1. Y minus 0, just y. Woo! -3x. 3 times 0 is 0. I have my direct variation equation. And then again, read carefully. Find x when y equals 6. And no, this is not an add opposite. We're multiplying by -3. So what's the opposite of that? Divide. And I find the variable that's being asked for. Sometimes it may ask for x, sometimes it may ask for y. I've got to pay attention to that. That's going to make a difference as we're working through some of those. But again, the work isn't really that hard once we give ourselves a shot. Like, all right, what else you got here, Hardy? We only got a couple of quick things to go here. Okay. Actually, no. Today is all this stuff. I know that hardly ever happens. There's always review, it seems like, but not in this case. Ooh, decimals. Yuck. Suppose y varies directly as x, write an equation. You're like, so that's all they're giving me? Yeah. So we know we got 0, 0. And we know we got -1.6, -4.8. Lots of little things we can do to make this go smoother. Got to find my slope. y2 minus y1, x2 minus x1, ooh, -4.8 divided by -1.6 is, ooh, that's bright and glary. Good old +3. You basically know what's coming. Let's think about this for a minute before we start plugging everything in. Let me go back on something. So check this out. When we did it in the notes, we found our slope. Then look at the equation at the end. Y equals your slope, x. When we plugged in our slope and our point, when you get down to the end, look at what the equation was. It was whatever your slope was, and then just x. And then you look at the next one we did, and we found the slope, and we plugged it in, and we got y equals the slope, x, and that was it. And then we did, like Hardy, okay, we're getting the point here. We found the slope. And then the equation was y equals the slope x. So let's save some time and some ink. Y equals the slope x. That's the equation. Now, if you're more comfortable plugging them in and distributing, that's fine. But you're going to end up in the same place. Find x when y equals negative 24. One step. What's the one step? Divide. And we're there. One last one to play with. Except I'm not going to do the distance and time one because you have an example of that. I'm going to the cupcake one because we still can make this work. Okay. Cost varies directly with the number of Sugar Jones cupcakes you can buy. An 8 cupcake costs $23.92. Find the following. Okay. So write a direct variation equation. Here comes the key. For the cost y of x cupcakes. They're telling us which one is x and which one is y. So, we know the deal. 0, 0 is always my first point. And then for my second one, x and y. It keeps coming back to the same thing. Oops, that's a y. So, let's find our slope. This one could be a little more interesting. So subtract my y's on top. Subtract my x's on the bottom. Whoops. I got to type it in right, though, to be able to get the right answer. 299. Now, that's not all I need to do for letter A. Write the equation, remember, is going to be y equals my slope, x. That's the equation I want. The equation basically says, hey, every cupcake costs $2.99. If I know how many cupcakes I bought, I can tell you how much that's going to cost. And speaking of, find the cost of 23 cupcakes. Well, the cupcakes is x. So y equals, replace the x with 23. Woofda. And I get my money. Okay. So again, you now have, between on the paper and on your notes, you have examples of everything. Be working on making sure your note packet is updated. We'll be using it as we work through the quiz preview tomorrow. And then you can use it again Wednesday when we get to the quiz itself. So put in your time right now. Give yourself that best shot to be successful on this. And we will go from there.